All right, so let's go ahead and take a look at this last one now. Um, yeah, so this last one's kind of a doozy. If you've had college algebra and you've worked through logarithms, then it's not as bad. If you've not taken that, then this one can be a little bit iffy. The main problem we have is that we're looking for the half-life here. If you think about your formula, half-life was the capital T, and that was buried inside of the exponent of our formula, and that's the part that makes this difficult. So the opposite process to exponentiation is doing a logarithm. Um, you can request to see this process if you're really interested, and I will show you or send you information on it. But otherwise, because we don't need college algebra for this class, some of you have taken it, some of you haven't. I'm just going to kind of give you the magical formula that helps us solve this one. And so it's going to look like basically the world's ugliest proportion. So you have the natural log of the original amount over the final amount. So notice that this is swapped around from what we had before, and that's to fix a negative sign that otherwise would show up in the work. Then we have the natural log of 2. So this fixes the thing where I mentioned earlier that we have the special number e. It's basically what's called the change of base formula, so it fixes it back around the other way. Then we've got the total time, and then the time for the half-life. Right, so that's our formula. The ln button, natural log, is a special function that's on your calculator. It's usually shared with a button that says e to the x, and it just reverses that process. All right, so plugging into this and looking at the units, milligrams and milligrams are going to cancel. We have hours. We're trying to get to hours, so that's not going to be a problem. We just need to plug in. So we've got the natural log of the original amount over the starting amount. So that's going to be 2267 over 760. Then this is over the natural log of 2. Then our time is 49 hours, and we don't know the half-life. So running through and solving this one, cross multiply and work it down. In the one direction, you get t multiplied by the natural log of 2267 over 760. And then on the other side, 49 times the natural log of 2. Now, it sounds like a bunch of scary, ugly stuff, but it's all basically calculator work. If you run it on through, eventually this works down, and you find that the half-life is 31.0773 hours.